Hi everyone. Now I am going to discuss about the next lecture, screw gauge. Earlier I have explained regarding the vernier calipers, how to calculate the least count of the screw gauge, how to calculate the least count of the vernier calipers, and how to take the reading. I have explained. Now today we are going to discuss about the screw gauge, how to take its reading, how to measure the pitch of a screw gauge, similarly how to measure the least count of the screw gauge, and what is a positive error, what is the negative zero error of the screw gauge, that and all we'll discuss. Okay, we can see I have taken a screw gauge diagram. This screw gauge is generally consisting of there is a U-shaped frame. You can see this is a U-shaped frame. It is having two studs. One is fixed stud, they are calling that is anvil, and other one is a spindle. It is another stud which is moving. And we can see there is a sleeve. On this sleeve, we can observe that there is a main scale divisions are there from 0 like that, and we can also observe that there is a circular scale. We can see the divisions on the circular scale. We can observe like a maybe it 50 divisions, maybe 100 divisions, maybe 150 divisions, maybe 200 divisions. As per the designed screw gauge, we can observe that. So whatever this shape is there, that whatever the circular scale is mounted on something, no cylindrical shape, that they are calling this thimble, that can be rotated. Okay, other one is at the end some knob type is there, no, that is called a ratchet. Okay, this is the overall arrangement of the screw gauge. Now I am going to tell one thing. Now if you want to take the readings, okay, if you want to take the reading and fix the object, this ratchet should be rotated clockwise. Okay, to fix the object between studs, and to take readings, this ratchet is there, no, that ratchet should rotate in clockwise. Next, now to bring this suppose say if two studs initially, the this case, to separate these two studs, to separate the studs to keep the object between studs, we need to bring some gap, now this gap. So in that case, ratchet should be rotated in anti-clockwise, counterclockwise or anti-clockwise direction. Observe this carefully. Whenever the two studs are contact each other, to bring the separation between the two studs, we have to move the ratchet in anti-clockwise direction. So once object is kept, to fix the object here, to fix the object between the studs and to take the readings, first of all the object should be tightened between the two studs. Now to tighten that, to fix the object, the ratchet should be rotated clockwise direction in that case. Okay, now this is a actually arrangement how to take the readings, and what is the error and all. I will show you a diagram type, you can see here. Okay, now you observe that there is a screw gauge. Here screw gauge is there. This screw gauge, I'm making little big screw gauge. This is a screw gauge. Okay, now I will do one thing. First, there is some gap is there, no, to close that gap, what I am doing is I am moving, suppose if I move in anti-clockwise direction, the space between the 2 studs is increasing. Observe this carefully. I am moving anti-clockwise direction. If I move this ratchet in clockwise direction, it is fixing. You can observe that it is fixing. Okay, you can see it is moving in a clockwise direction. Whenever it is moving in a clockwise direction, we can see that it is moving. Okay, it is fixed here. Okay, now you just observe that I have taken like a 0 division on the circular scale is coincide with the linear scale. Whenever it is coinciding on the linear scale, we can observe that there is no zero error. That is the case here. There is no zero error. Okay, now if I place any object here, we can see the diameter of this cylinder, we can see 4.50 millimeter is there. You can see how many divisions on the linear scale. There are 0, 1, 2, 3, 4 divisions are there. Each division is called one main scale division, or one pitch scale division, or we can say one pitch of the screw gauge. So you can say 1 millimeter. So 4 divisions are there. 4 into each division is 1 millimeter. So 4 millimeter. Which division is coinciding here? Circular scale division. 50 division is coincide. Let us consider there are 100 divisions on the circular scale. Pitch divided by the number of circular scale divisions gives the least count of the screw gauge. So we'll get the 0.01 millimeter is the least count. So we can say that 4.50 finally you will get nothing but circular scale reading can be written as least count into 50. We will get the 0.01 into 50. Finally you will get 0.50. That we can see here 4.50 is the diameter of this cylinder. Let us consider diameter of the cylinder will not at all change actually. Understand that if you change the diameter the cylinder by taking the more diameter, then you can observe that reading will change. Otherwise that 4.50 every time, whether it is 0 error is there, or positive 0 error is there, or negative 0 error is there, that 4.50 will not change. Okay, now I am taking one example. You can see here, now I am removing this. Again, what I am doing is just you connect the both the things here, touching each other. Now whenever it is touching like this, I am making this as some error. How much error we want now? Let us consider that 5. Okay, 5 I am keeping here, -5. Okay, -4 is there. Let us consider it is if -4 is there. In that case, we can see 0 division on pitch scale is barely visible. We can say only little part of the 0 on the main pitch scale is visible. But we can see which division is coincide here. 0 division on the circular scale is lies above the linear scale, and which division is coincide here with that linear scale line, index line we can call, with that line 96th division is coincide. Nothing but if you turn in anti-clockwise direction, gap will increase. If I turn clockwise direction, it is fixed already. Now in that case 96th division is coincide. Okay, now I am placing any object, whatever this error is there, no, that is called negative 0 error. Okay, that error is actually you can write it as least count into coinciding division. Coinciding division means you should not write like a 96. So above that, below the 0, how many divisions are there? 4 divisions are there. So error division is 0.04 millimeter we have to write. Okay, error is 0.04. Now if I place the object, Again we can see in this case 4 divisions we can see on the pitch scale. So 4 millimeter is the pitch scale reading. This time the circular coincident, no, it is changed. How much is there now? It is coincident as 46th division is coincide. That's why 0.46 plus 4 is 4.46. Again if you see that 4.46 millimeter and error is negative, error is there, now we have to add. Finally the diameter of the cylinder will be same 4.50. That will not change. Understand that? Maybe our circular scale reading will change, that's all. But 4.50 is there, no, that will not change. Now if you want, we can see I will make the error is some other thing. Positive 0 error I will make. Suppose say I kept the 6. Okay, now again I am changing clockwise. I am turning this to fix the studs. Okay, to fix the studs clockwise we have to rotate this ratchet. I have rotated clockwise. In this case 6th division is coincides here. Now 0 on the circular scale is lies. How many divisions is below is there now? 0, 6 divisions below. Sorry, actually 0 is 6th division is coincide is nothing but 6 divisions are ahead. Okay, or we can say that 0 is below the reference line or index line. So error is plus 6 into least count. 0.06 millimeter is the least count. Now if I place any object here, we can see again what division is going visible on the pitch scale here. 4th division is visible on the pitch scale. If it is 4th division is visible, we can write 4 millimeter is the pitch scale reading, and corresponding whatever the circular scale reading is there, no, that we can see 56th division is coincide. This time only circular division is changed here. So you can see that 4.56 millimeter is the reading, and already earlier we got positive 0 error. Now we have to subtract it. If we subtract that, finally again we will get the our cylinder diameter is 4.50 millimeter only. Understand how to take the negative 0 error and positive 0 error. This is the use of this screw gauge. By using this screw gauge we can calculate the diameter of any cylinder, as well as a sphere, diameter of the sphere. Similarly length of any object also, if you want, we can calculate. Understand that? For more details, if you want, we can see here 0 error. Suppose say if this index line is there, no, this index line is actually coinciding with the 0 on the main scale, on circular scale. This is possible when there is 2 studs are contact each other and no object is kept. In that case 0 this is called no 0 error. Okay, now suppose say 2 is a circular main scale reading and 25th division is coincide. They got the 2.25, just they have added. Okay, next in this case we can see next case 0 is lies below the this index line, okay, or reference line. Okay, in that case you can see which division is coincide here. 7th division is ahead. Okay, 7th division means 7th division is coincide. The whatever error is there, that is called positive 0 error. Positive 0 error is nothing but if the 0 on the circular scale is lies below the reference line or index line when 2 studs are contact each other, that error is called positive 0 error. And finally you have to subtract that. Again reading is 2 is given, the circular scale reading is changing here to the 32 division is coincide. This time 2.32 we are getting. Finally we can see that 2.32. now we have to subtract this. If we subtract 2.25 here, this answer is the same only. Similarly whenever 2 studs are contact each other, if the 0 division is above the reference line is there, now we can see which division is coincide. They have taken here 50 divisions circular scale. In the 50 they have taken that minus 0.02 is there. What is meaning of minus 0.02? Here 48th division is coincide here. Which division is coincide? 48. So below the above the 48 to get the 0, 2 divisions are there. That's why you are taking 48th division. But while multiplying 48 into LC, you should not write. What you have to write here? Total 50 divisions minus 48. That is 2 divisions you have to add. Okay. To bring the 0 down, 2 divisions it should go down. No, that's why 2 into least count you have to write. So 0.02 you will get. This error is negative. Finally, to get the corrected reading, you have to add 0.02 to get the final value is how much here? 2.25 millimeter only. In this case, you can see 2 is the pitch scale reading, and 23 division on the circular scale is coincide. Finally, we will get the 2.23 millimeter. Okay, this is what actually we are going to observe. Okay, now some formulas are required. No, that I am writing here. Whenever a screw gauge is given, when we are using screw gauge, we should know few things. What are the few things? What is the each division on pitch scale? Each division on pitch scale, that we should know. How to calculate this each division on pitch scale? That is called pitch also you can call. Okay, that pitch can be written as distance moved by linear scale divided by the number of rotations. Which is rotations here? I am turning the ratchet now. That rotations we have to see here. Okay. Based on that, we will see that what is the pitch. Okay. Next one, after finding the pitch, we have to calculate the number of divisions on circular scale. You have to observe that number of divisions on circular scale. After knowing number of circular scale divisions on circular scale, calculate least count of screw gauge. Least count of screw gauge. That least count of screw gauge can be written as pitch divided by the number of circular scale divisions. Number of circular scale divisions. Number of circular scale divisions. That is the way to calculate least count of screw gauge. Sometimes this smallest division is there, no, on the pitch scale. They may call that least count of the main scale also they will call. Okay. Next one, after knowing this, first we have to see that when two studs are meet each other, no object is kept. No object is kept. In that case, we have to identify the zero error. Zero error. How to identify zero error? If this linear scale and this circular scale, if you observe that, if 0 is coinciding here, no error. Okay. Suppose say if it is looking like this, 0 is like this is there. Let us consider there are the 50 divisions, 50 circular scale divisions. In these 50 circular scale divisions, let us consider the 47th division is coincide. We can write it as 48, 49, 48, 49, 50. We can see below this to get the corrected reading, it should move down by how much here? 3 divisions gap is there. 3 divisions gap. So here negative error we can write it as negative error is 3 divisions into least count minus 3 divisions into least count we have to write. So in final answer we have to add it. In final answer, while measuring diameter of any object, object, we have to add plus 3 into least count value. Okay, suppose say if it is given like this, if 0 division is below is there, let us consider 1, 2, 3 division is coincide. In this case, to get the corrected reading, 0 should move upward by how many divisions? 3 divisions it move up. Okay, so you can say that error is positive error, and we can write plus 3 into least count. In final reading, when object is kept, okay, in final reading we have to subtract this value 3 into least count value. Okay, this is actually process to do the positive 0 error as well as negative 0 error. These all actually I am telling before object is kept. Now if I keep the object, now place the object between two studs. Identify pitch scale reading. Pitch scale reading is pitch into division on pitch scale, or 1 MSD into division on pitch scale. Next one, identify circular scale reading, that is coincidence division into least count. Next, final reading or corrected reading. Corrected reading can be written as pitch scale reading or main scale reading plus circular scale reading. We have to write minus or plus error. If it is positive error, you subtract. If it is negative error, we have to add it. This is what actually process throughout the screw gauge we have to follow this. Is it clear now? Now we are going to discuss some problems which they have actually asked in JEE mains exam and JEE advanced exam. Look here, the least count of the main scale of the screw gauge is 1 millimeter. You observe this carefully. Least count of main scale of screw gauge, nothing but 1 main scale division is equal to how much? 1 millimeter is there. Next, the minimum number of divisions on the circular scale required to measure 5 micrometer diameter of the wire. Now you can see that finally how to get the 5 micro diameter of the wire. Whenever any object is kept between the two studs of the this screw gauge, we are going to observe that 5 micrometer we have to get. When we will get the 5 micrometer, you see first you calculate the least count of an object. When least count can be written as this is also called pitch here. Okay, pitch divided by the number of circular scale divisions. They are giving the reading value is 5 micrometer we have to get. As there is no main scale reading, only this number of circular scale divisions into least count only gives the value. Okay, suppose this value is 5 into 10 to the power of minus 6. Okay, as there is no main scale reading, this pitch value is equal to 1 millimeter divided by the 1 millimeter is nothing but 1 into 10 to the power of minus 3 divided by the number of circular scale divisions. You observe this 10 power minus 3, 10 to the power of minus 3 time to get cancelled. N is equal to, you can write it as 1 by 5 into 10 to the power of minus 3. So we can write it as 1000 divided by the 5, that is equal to 200 divisions are there. So answer will be 200. There is no reading actually, just they are asking that to get the 5 micrometer diameter, what should be, how many number of divisions should be there? 200 divisions should be there. That's all. Next one, we can see if in 5 complete rotations of the circular scale, the distance traveled on main scale of the screw gauge is 5 millimeter. There are 50 total divisions on the circular scale, then least count is how much. Now we can see how much distance is there here. Distance traveled on main scale is 5 millimeter. Okay, for how many rotations? 5 complete rotations. We can see pitch is equal to distance traveled is 5 millimeters divided by the 5 rotations. We can say that 1 millimeter is the pitch. The same value we can see 0.1 centimeter is the pitch. Now least count can be written as pitch divided by the number of circular scale divisions, n. 0.1 centimeters divided by the 50. You can get the value as 0.01 divided by the 5 centimeters. That is 1 by 5 is 0.2, no? So we can write 0.002 centimeters. But in question, they have given 0.001 centimeters. So we can say assertion is wrong. Now you check that reason. Least count is equal to pitch divided by the total number of circular scale divisions, which is correct. In the light of the above statement, choose the most appropriate answer from the options given below. So we can see assertion is wrong and reason is correct. So second option is the correct option. Now I am moving to the other question. They have asked in 2020 JEE Mains. A screw gauge has 50 divisions on circular scale. A circular scale is 4 units ahead of the pitch scale marking prior to use. Upon one complete rotation of the circular scale, a displacement of 0.5 millimeter is noticed on the pitch scale. The nature of the zero error involved and least count of the screw gauge are what? Now we can see complete rotation pitch can be written as per the question, pitch is equal to distance moved is 0.5 millimeter divided by how many divisions are there here? 50 division one complete rotation they have given, so we can write it as 0.5 millimeters. Now we can write least count can be written as pitch is 0.5 millimeter divided by the number of circular scale divisions 50. So finally we will get 0.01 millimeter. This is my least count value. This least count can be written as 0.01 into 10 to the power of minus 3. That is 10 to the power of minus 5 meters is there. So 10 to the power of minus meters is 10 into 10 to the power of minus 6 meters. That is 10 micrometer. This is my least count value. Apart from this, we can see that whenever this screw gauge is taken, we can see zero division is below is there. How many divisions are there? 1, 2, 3. Fourth division is coinciding. If fourth division is coinciding, we can see 0 is below the reference line. If it is below the reference line, error is positive. Error is positive. Here positive error value is equal to how much? 4 into least count. 4 into least count will add. This is error. Okay. Anyway, they are asking only whether it is positive value or negative value. They are asking. It is a positive value. I am moving to the next question. A student measured the length of a rod and wrote it as 3.50 centimeters. Which instrument did he use to measure it? Meter scale. What is the least count of meter scale? Least count of meter scale is, you can write it as 1 millimeter, that is 0.1 centimeters. So we can measure by using meter scale up to 1 decimal place only. 1 decimal place. So meter scale is wrong option. Now you can see a vernier scale 10 divisions is matching with the 9 divisions in main scale, and each division is 1 centimeter they have given. So we can see that 1 VSD is equal to 9 divided by the 10 main scale divisions. That is 0.9, main scale division is 1 centimeter is given. We can write 0.9 centimeters. If it is 0.9 centimeters, we can see that main scale has 10 division. Sorry, main scale is not 1 centimeter. 1 MSD rate, that's all. Okay, 0.9 millimeters. Not millimeter, also MSD. 0.9 main scale divisions, that's all. Now you can see 1 MSD value is how much? 1 MSD value is equal to, they have given that main scale has 10 divisions in 1 centimeter. So nothing but in 1 centimeter 10 divisions are there. We can write it as 0.1 centimeter is the MSD. You substitute that value, overall 1 VSD value is equal to 0.9 into 0.1 centimeter. We'll get 0.09 centimeters. This is VSD value. Now we can see least count is equal to 1 MSD minus 1 VSD. 1 MSD is 0.1 centimeters minus 0.09 centimeters. Overall we will get 0.01 centimeters. Now you can see by using this, by using vernier scale, given vernier scale, we can measure up to 2 decimal places. 2 decimal places. So now given measurement also 2 decimal places is there. So we can say second option is the correct option. Anyway, you will check for the screw gauge also what is happening. Now we can see least count of screw gauge. Least count of screw gauge, we can write it as pitch is 1 millimeter divided by the 100, you will get the 0.01 millimeter, that is 0.001 centimeters. Here we can measure up to 3 decimal places. Up to 3 decimal places. So our answer should be not the 3.50, it should be 3.500 centimeter. Then that will be correct. Okay. Similarly, if it is 50 divisions is there, obviously we will get the same kind of relation, which is not possible. So second option is the correct option. We can check that. Okay. Next one. This question they have asked in JEE Mains 2016. A screw gauge with a pitch is 0.5 millimeter and circular is having 50 divisions. I am calculating least count. 0.5 millimeters pitch divided by the 50 divisions. You can get the value is 0.01 millimeters is the least count. Now we can see before starting the measurement, it is found that when the 2 jaws of the screw gauge are brought in contact with the the 45th division coincide with the main scale. You observe this carefully. When 2 studs are contact each other, whatever the 45th division is coincide. Now you can see 46, 47, 48, 49, 0 division is here. You can see here 5 divisions below coincide division is there. So nothing but whatever error is there, you will write the negative error. So you can write error value is equal to minus 5 into least count. We can write minus 0.05 millimeters. Now you see what is the main scale reading. I think I can calculate the main scale reading here, or pitch scale reading 0.5 millimeters. Now circular scale reading can be written as 25th division is coincide here. We can see 25 into least count, we can write it as 0.25 millimeters. Now finally you can get the 0.75 millimeter is the general reading. Corrected reading, if you calculate the corrected reading, you can write 0.75 millimeter. Now error is negative is there, now you have to add 0.05 millimeter. So finally you will get 0.80 millimeter. I am telling this is whether positive zero error is there, negative zero error is there. This value is whatever diameter of the given object is there, that will be always same 0.80 only will get. Okay, next one, pitch and number of divisions on the circular scale given screw gauge are 0.5 millimeter and 100 respectively. Now we are going to calculate the least count is 0.5 millimeter divided by the 100. We can write 0.005 millimeter. This is the least count. Now we can see that when screw gauge is fully tightened without any object, the zero of the its circular scale lies 3 divisions below the mean scale, line they have given. So you can see the 0 division is there, actually lies below 1 2 3. Third division is coinciding here. We can observe that the error is positive error. That positive error can be written as plus 3 into 0.005 millimeter least count. So you can get 0.015 millimeter is the error. I have written error value. Now you can check that what is the main scale reading. MSR can be written as 5.5 millimeters. Now circular scale reading I am writing 48 into least count, that is 48 into 0.015 millimeter I have written. So now corrected reading I am writing. Corrected reading, if you write the corrected reading, that value is 5.50 plus 48 into 0.015 and positive error is there, now you have to write minus 0.015 millimeters. If you do this calculation, you will get the first option. So 5.725 millimeters you will get. We can do that calculation. Okay, first option is the correct option. Next one, they are asking thickness only. Okay, if they ask radius, now you have to be careful. By 2 you have to do. Okay. Next, a student in the laboratory measures the thickness of a wire using a screw gauge. The readings are 1.22, 1.23, 1.19 meter and 1.20. There are 4 readings they have taken. We have to take first mean value of this. I am taking x mean value can be written as 1.22 plus 1.23 plus 1.19 plus 1.20 whole divided by the 4 you have to write. I am adding this 1.22, 1.23, 1.19, 1.20. Now you can see 5 and 9, 14, 4, 5, 7, 8, 4.84. So we can write 4.84 divided by the 4, we will get the 1.21 millimeters is the x mean value. I calculate x mean value. Now delta x1 value is, we can write as modulus of 1.21 minus 1.22. Finally I will get 0.01. Delta x2 value is modulus of 1.21 minus 1.23. I will get the 0.02. Delta x3 value is 1.21 minus 1.19. I will get 0.02. Again delta x4, error in the fourth reading is 1.21 minus last one is 1.20. So I will get the value is 0.01. If I add all the things, I will get 0.0456 will get. So delta x mean value, if I write that, I can get the 0.06 divided by the 4. I can get 0.015 millimeters. This is the delta x mean value. They are asking what is a percentage error. The percentage error can be written as delta x mean divided by the x mean value into 100. You can get the 0.015 into 100 divided by the 1.21. If you write the value is 100 get cancelled, so you can write it as 15 into 10 to the power of minus 3 into 100 divided by the 121 into 10 power minus 2. We can see minus 2 minus 1 time get cancelled. Finally, we will get 150 divided by the 121 percentage. So in this percentage, what they are asking, what is the value of x? X is equal to much? 150 is the x. Okay, these are by using screw gauge only they are measuring. That's why I have taken. Okay. Next one. A pitch of the screw gauge is 1 millimeter and there are 100 divisions on the circular scale. When nothing is put between the jaws, the zero of the circular scale lies 8 divisions below the reference line. Below the 8 line means error is, first you have to write least count. Least count is pitch is 1 millimeter divided by the 100, you will get the 0.01 millimeters. Now positive error is there. That positive error can be written as 8 into least count, that is 0.01, we will get the 0.08 millimeters. Now you can see main scale reading is how much. Main scale reading is, we can see that which division, first linear scale is clearly visible. So 1 millimeter is this. And circular scale reading can be written as 72nd division is coinciding, 72 into 0.01 millimeters. So finally we can get the 0.72 millimeters. If we add this, 1.72 millimeter is the reading, and corrected reading is how much? Corrected reading. Reading, if you see that 8 divisions below the reference line. Now you can see what is the value of this. 1.72 minus 0.08. If you write this 1.64 millimeters, you will get. This is diameter. This is diameter. Now you want radius. Radius of an object is diameter 1.64 divided by the 2 millimeters. You can get the 0.82 millimeters. This is the answer. Why I am telling is they have given 1.64 also. After doing this much calculation, if you write only 1.64 millimeter without reading the radius of the wire, then you will get wrong answer. Okay, kindly see that they are asking radius. Radius is the first option. Okay, next question. Now this is the 2021 mains question. A student A and student B used two screw gauge of equal pitch and 100 equal circular scale divisions to measure the radius of the given wire. The actual value of the radius of the wire is 0.322 centimeters. The absolute value of the difference between the final circular scale readings observed by the student A and B is what? Now we can see as the actual radius of the wire will not change. That is same 0.322 centimeters only. But where the problem is coming, maybe some error will be there in the both the readings. Okay, that they are not telling also. Now person observer first student is measuring how many divisions are there? 5 divisions are there. Okay, now second person is there. If you see that second person and first person, if you observe that 92, here 95, 96, 97, 98, 99, and here you let 0, 1, 2, again 3, 4, 5. This 5 indicates that student A division, and E is measuring with 98. So total how much gap is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So total the gap between them, you can see here 5 divisions is there. Here how many divisions are there? From 92 to 0, 8 divisions are there here. Here 8 divisions, here 5 divisions. Now they are asking what is the difference between them. 13 division is the difference between them. Okay, what is the difference in that? Difference will be, you will get circular scale reading observed by the student A and student B. What is the difference between the final circular scale reading? 13 divisions, that's all. So answer is what here? 13 is the answer. You have to understand question properly. They are asking difference in circular scale, that's all. Next one, this is the question from the JEE Mains 2022. In this question, they are asking to find out the diameter of a wire using screw gauge. The following observations were noted. Screw gauge is 0.5 millimeter on main scale, one complete rotation. Nothing but pitch is equal to 0.5 millimeters. Number of divisions is 50 they have given. Least count is 0.5 millimeter. Pitch by 50. You will get 0.01 millimeter is the least count. Main scale reading is 2.5 millimeter. So you can write 2.5 millimeter is the main scale reading. Next, 45th division is coincide. Then we can write it as 45. Circular scale reading is 45 into 0.01 millimeter. So now you will get the 0.45 millimeters. Okay. Now if you calculate this, 2.95 millimeters we can write. This is a reading actually. But if you see for next bit, they have given instrument as 0.03 millimeter negative error. So now corrected reading is how much? Corrected reading is 2.95 millimeters. Negative is there, that's a plus we have to write 0.03 millimeters. Finally, you will get 2.98 millimeters is the answer. So you can tick the 2.98 millimeters. See, third option is the correct option. Now you can see next question. A screw gauge of the pitch is 0.5 millimeter is used to measure the diameter of the uniform wire of length is equal to 6.8 centimeter is given. Okay, length of the wire is given that 6.8 centimeters. Next, the main scale reading is 1.5 millimeter. Main scale reading they have given. I am writing main scale reading is 1.5 millimeters written. Next, circular reading is 7 and it is having 50 divisions on the circular scale. You can see screw gauge pitch is equal to much 0.5. I am writing least count is pitch 0.5 millimeters divided by the 50. You will get 0.01 millimeter. I want in terms of the centimeters. I can write later also. Okay. Seventh division is coincide. So circular scale reading I am writing. Circular scale reading is 7 into least count is 0.01 millimeters. Overall, if I add that, I can get the 1.50 plus 0.07. So that value is 1.57 millimeter is the my total reading. This is my reading is 1.57 millimeter. If reading is 1.57 millimeter, answer they have given centimeter now. 1.57 divided by the 10 centimeter is my reading. Now after this we can see that they are asking calculate curved surface area of the wire to appropriate significant figures. Now what is a curved surface area? Curved surface area, you can write it as 2 pi r into L. Whatever value I got, like a 1.55 is there, no, that is diameter. But I don't want diameter, I want radius. If I write radius value 1.57 centimeter divided by the 2 into 10. Okay, earlier we got the this value, 1.57 by 10 centimeters by 2 we have to write. You substitute there 2 into 3.14 into radius is 1.57 divided by the 2 into 10. Length is 6.8. Overall, we will get the value is in centimeters square we will get. You do the calculation. I calculated already. I am getting 3.354. 3.354 centimeter square I am getting. But if you observe that, actually whatever measurement we are making, we are getting the measurement is 1 point, main scale reading is 1.5 millimeter is there. Okay, and our answer also you have to get like a least significant figures. What are the least significant figures in this one? I can get the here 3.14 is there, 3 significant. Why? Because I am multiplying, no, that's why 1.57 is having 3 significant, 3 significant. 6.8 is having 2 significant, 2 significant figures. Now as per the our relation, while multiplying and dividing, we have to see least number of significant figures in the operation, operation. See, this is important line here. Now you have to see that our answer should be least values 2 significant figures. So in 3.354 centimeter square, to make the 2 significant figures, we need to drop this. While dropping, you have to use the significant figures. See here. So now preceding digit is odd. This is what here? Odd. Whenever 5 is dropping, preceding digit is odd is there, then that odd number will be raised by 1. So you can get the 3.4 centimeter square. Odd number 3 is there, that will be raised by 1, 3.4 centimeter square. So second option is the correct option. Okay. Next one I am taking like a in JEE Advanced 2011 paper 2, they are asking this. The density of the solid ball is to be determined in an experiment. Diameter of the ball is measured with a screw gauge of pitch is given 0.5 millimeters. So I am writing pitch is equal to 0.5 millimeters. Next 50 divisions are there, least count is 0.5 millimeters divided by the 50. I will get 0.01 millimeter is the pitch. The reading on the main scale is 2.5 millimeter. So I can write the 2.5 millimeters. And circular scale is 20 divisions. So circular scale reading is equal to how much? 20 into least count is 0.01 millimeters. I will get 0.20 millimeters. Now if I calculate the both the things, my reading is equal to how much? My reading I will get like a diameter D is equal to 2.70 millimeter is the diameter. They are asking that relative error of the mass relative error is 2%. What is the percentage error in density they are asking? So you can write it as density D is equal to mass divided by the volume. Mass divided by volume is 4/3 pi r cube, you can write. 4/3 pi r cube we can write. As r is equal to d divided by the 2, you can write it as m divided by the 4/3 pi d cube divided by the 8 you can write. Okay. Now percentage error you have to write delta d divided by the d into 100 is equal to delta m divided by the m into 100. Only you have to see d term. Okay. Now 3 into delta d divided by the d into 100. Delta m by m is given 2%. 3 into delta d by d value is 2.70 percentage. So if you calculate this value, you will get the some value. You can write the sorry, I wrote wrong here. Delta d is not the this value. No, delta d is how much? The error in this least count you have to write 0.01. Here whatever error is there, 0.01 millimeter divided by the 2.70 into 100. So finally I can get the values 2% plus 100 into 0.01, one time get cancel. So 2.3 by 2.70. Approximately you can get the value is 1.1%. So 3.1% is our final result approximately. Okay, observe this carefully. Next one, they are asking in the determining the Young's modulus, they have given the value y is equal to 4 mlg by pi l d square. By using Searle's method, a wire of length l is equal to 2 meter and diameter is 0.5 millimeter is used for a load of m is equal to 2.5 kg and extension is l is equal to 0.25 millimeter in the length of the wire is observed. Quantities d and l are measured using the screw gauge of the micrometer and a micrometer respectively, and they have the same pitch 0.5 millimeter. The number of divisions on the circular scale is 100. Now answers they are asking like the errors measured errors are there, no, in d and l are same or different, that is a question actually. Okay, now you can see delta y divided by the y can be written as only errors are there in l and d only, so delta l divided by the l plus 2 into delta d by d. Okay, now we can write error in y is equal to y into delta l by l plus 2 into delta d divided by the d. Now you check that this term is error in l. Error in l. This term is not that, whole term is we can see that error in d. Already all values are given. You can see pitch is equal to 0.5 and all they have given. Least count can be written as 0.5 divided by the 100. We can get the 0.005 millimeters we will get. This is my least count value. If you know the least count value, you can get the value of delta L by L as well as delta D by D value. You calculate and get the answer. You can get the in L value, you can see that y into 0.005 divided by the 25, 0.25 plus 2 into delta d by d. Again you let the 0.005 divided by the value of d is equal to 0.5 they have given. So if I do this, 2 divided by the value is 0.25 only. Now the value, this value and error in L value and error in D value both are same. Okay, no need to calculate also, just you can see that due to errors in the measurement of D and L are same. Okay, first option is correct option. Next one, consider a vernier calipers in which each 1 centimeter on the main scale is divided into 8 equal divisions. Nothing but we can see that main scale 1 MSD value is given that 1 centimeters. No, we can see 1 centimeter is divided into 8 equal divisions. Nothing but 1 MSD value is equal to 1 by 8 centimeters. Again, screw gauge is 100 divisions are there. Vernier calipers is 5 vernier scale divisions coincide with 4 main scale divisions. I can write the 1 vernier scale division is equal to 4 by 5 main scale divisions. I can write the 0.8 main scale divisions. Already 1 main scale division is this, you substitute there, that is equal to 0.8 into 1 divided by the 8 centimeters. That can be written as 0.1 centimeters. 0.1 centimeter is a 1 VSD. That is also you can write 1 millimeters. Why? Because answer they have again in millimeters. We can see 1 millimeter. So what is the least count? Least count can be written as 1 MSD minus 1 VSD. 1 MSD is 1 centimeter, nothing but 10 by 8 millimeters we can write. 10 by 8 value can be written as 5 divided by the 4 millimeters. Okay, 5 by 4 millimeters minus 1 millimeters. We can get the value is 1 by 4 millimeters. This is the least count of this. If least count of this value is 1 by 4 millimeter is there, Same thing can be written as 0.25 millimeter is the least count of vernier calipers. Vernier scale. Vernier calipers least count is this. Now you can see that they are asking the some values. If the pitch of the screw gauge is twice the least count of the vernier calipers. Case 1. Pitch of the screw gauge is 2 times the least count of vernier scale. If it is like this, we can write it as 2 into 0.25 millimeters. That is equal to 0.50 millimeters. Okay, 0.50 millimeters. And they are asking what is the least count of the screw gauge. Least count of screw gauge means screw gauge is how much is having 100 divisions. Now we can see least count of screw gauge. Least count can be written as pitch 0.50 millimeters divided by the 100. If you write that 0.0050 millimeters will get. So where 0.050 is there? So this option is wrong. B option is correct. Next one, if the least count of the linear scale on screw gauge is twice the least count on vernier calipers. Again you see here. In the second case, they have given 1 MSD is a least count on that. That is equal to least count of linear scale is how much here? 2 times the least count on vernier scale. So 2 times the least count on vernier scale is 0.25 millimeters. We can get the 0.50 millimeters. In this 0.50 millimeters, again you see in the question they have given that one complete rotation of the circular scale moves by 2 divisions on linear scale. Understand that? If it is moving 2 divisions on circular scale, then what value will you tell me now? So now we can write it as pitch is equal to 2 divisions, 2 into MSD divided by the 1. So you can write it as 2 into 0.5 millimeters, that is equal to 1 millimeters. Now least count of the screw gauge is pitch is 1 millimeter divided by the 100, that is 0.01 millimeters will get. 0.01 millimeter means, see, third option is correct. Fourth option also the same they are asking. So correct options are B and C are correct options. I hope you have understand this. This is about units, measurement and dimensions. There are some other experiments also there. I have tried to give like a vernier caliper, screw gauge, time period of the simple pendulum questions I have given, and I also given that few questions related to the Young's modulus also. Okay, maybe some questions also I have given like a capacitors finding errors I have given, focal length of the lenses formulas also I have done one or two questions based on that, and resistors also series and parallel questions I have done in errors. Similarly, meter bits and other instruments also there that usually you will get in current electricity chapter also. Okay, this is about units and measurement. I hope this chapter will be useful for your both the JEE mains preparation as well as JEE advanced preparation. I will start the next chapter like motion in a straight line or any other chapter. Thank you very much.